Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes, okay? So we're going to be talking about the seventh law today, which is the positive fractional power. And please try as much as possible to review the previous video, okay? So that it will be of help to you, because if you don't review the previous video, it's going to be a little bit difficult, okay, for you to talk about this. And also try as much as possible that if you have any question or any law that does not make sense or you're really confused, try to solve it from the textbook. And if you can't solve it, you can just send me an email and we're going to talk about it together. Is that all right? Okay, so what we're going to do now is we're going to go straight to it. And if you've not subscribed, I don't know what you're waiting for. Please do subscribe so that when I post new videos, you'll be the first person to know. So we're going to talk about the positive fractional power. Now, the positive fractional power, this law applies to, when the index is a function. Is that okay? So when you have an index as a function, then this law will apply. Now, there are three things that I need you to keep in mind with this law, all right? So the first thing is that the denominator, okay? So the denominator of the power, right? Of the power is the root of the base. Okay, I'm going to explain that very soon. So the denominator of the power is the root of the base. And also, the numerator now is the power of the base. The numerator of the power is the power of the base. Okay. For those that missed my video on basic algebra, I told you that when we talk about numerator and denominator, basically it's when you have a fraction like a divided by b, then a is what we call the numerator, okay? And b is what we call the denominator, all right? So this is what I'm just trying to refer to here. So the numerator in the fraction, the top one is the numerator and the bottom one is the what? The denominator, all right? Okay, so just to remind us of that, we talked about this, so please, if you missed the video, go back and have a look. Then number three is that when you've done that, so you have to then simplify as necessary, okay? So, as you deem appropriate, okay? As deemed appropriate. Okay, so that is that. So what I'm trying to say, so for example, if you have a raised to power 1 over m, so are you seeing? In this case, in the power, m is the what? The root, okay? So it's going to be the mth root of what? A, while 1 is going to be raised to power 1, okay? So, or you can say the mth root a raised to power 1, all what? The mth root. Are you seeing it? So let me write this better so it's a bit to be clearer. So it's going to be, either you say this or you say a raised to power 1, all of them to the mth roots. Are you seeing it? So because of this, anything raised to power 1 is the same thing. We always refer to this as the mth root of what? A. Are you seeing it? Now, if you have a constant, so if you have something like a constant, so we have Ka 1 over m, it's going to be K multiplied by either you say the mth root of A all raised to power 1, or you can say K multiplied by the mth root of a raised to power what? 1. So any of them, you can use that and it will give you the same answer. The next one is when we have, for instance, we have a raised to power n over m. So now in this case, it's still the same thing. So it's the mth root of a all raised to the power of what? N. Or you can easily say, depending which one you prefer, you can say it's a raised to power n, then all of this, the mth root of it. So you can use any of them, depending the value or the value of a, the base will now determine what to do. Now the other one as well is that you can also have k a n over m. So like I said, with all coefficients of indices, So the coefficient is just multiplying the resultant solution. So that means we already know that A and M is the same thing as saying what? The mth root of A, all raised to the power n. So the value you have there, you multiply it by what? K. The same thing. Or you can have it like this. It's going to be the A raised to the power n. All of this is going to be what? The mth root. And that will be the answer for that. So we're going to pick some examples now so that we can explain the concept. So let's assume we have, number one, let's say we have 9 raised to the power 1 over 2. So like I said, with the first one, it's the same thing as saying 2, the square root of 9. So that means 2 will be outside and 9. And which is the same thing. What's the square root of 9? And that will give us what? 3. Now, this is the same thing if you have something like, let's say we have P 27 raised to the power 1 over 3. Are you seeing it? So this is the same thing as saying P multiplied by the cube root of 27, all raised to the power what? 1. Like I said, because identity raised to the power 1 is the same thing. So usually when we have 1 here, we just assume that is the same thing. So the cube root of 27 is 3. So it will be P times 3, and the final answer you'll get is going to be 3P. The next one is, let's assume we have 81, 3 over 4. Now remember what I said in the previous slide? I said that when you have A n over m, the power, the denominator of the power is the root, while the numerator of the power is the power of the what? Of the base. So we're going to do the same thing here. So that means it's going to be the 4th root of 81. Are you seeing it? All raised to power what? 3. Okay? Or you can say 81 raised to power 3 or the 4th root. So like I said, depending which one is easier for you will now determine the best one to use. So for me, personally, I will prefer to use this one because it's easier for me to get the 4th root of 81. And the 4th root of 81 is what? 3, okay? Because 3 times 3 times 3 times 3 is equal to what? 81. All right, so that means 3, then we raise to the power 3, and that will give us what? 3 to the power 3 will be 27. Okay. Now that will be that for that. Number 4, let's assume we have a coefficients now, and we have 3, 27, 2 raised to the power 3. So like I said, if you have a coefficient, you just multiply the resultant value for that, okay? So if you go here now, it's going to be 3 multiplied by the cube root of 27, all raised to the power what? 2. Or you can say 3 multiplied by 27 raised to the power 2, then the cube root. So like I said as well, any of them should give you the same answer, but I'll prefer to go for this because it's easier to solve. Because I know the cube root of 27 to be what? 3. Then with 3 raised to the power what? 2. Okay? Based on the laws of BODMAS, so for those in when I talked about it in basic algebra, so for those that have reviewed that, you will notice I told you for BODMAS or BIDMAS, all right? Some of you call it BIDMAS. On textbook, we call it BIDMAS, all right? I told you that you have to solve the brackets first. So we're going to solve the brackets first. So it's going to be 3 multiplied by 9, and the answer you get is what? 27, okay? So that is the answer for that. So that is it for that. So that means basically what I'm saying in this rule is that when you're having a base raised to power to a fraction, all right, or a fraction, regardless if the base is a fraction or just a single base, all right, the fraction that is being raised to the power, the numerator of the fraction is the power of the base, while the root of the base is the denominator. Then you apply the rules as it is. And that'll bring me to the end for this video. The next law will be law 8, where we talked about the positive fractional base power and brackets with powers, okay? So if you have any question, like I said, feel free to send me an email and I'll get back to you. And also, please, if you are confused, try and solve some questions from the textbook or the worksheets. And if you still don't understand, just try and reach out to me either through the comment section or through my email, and I'll get back to you on it. So don't forget to subscribe, and I'll see you in the next video where we'll talk about the 8th law of indices. All right? So see you soon.